Welcome you all. I'm Dr.G.Saravanan. I'm working in Erode Sengunthar Engineering College. Today we're going to present data structure concept and get point of view. Particularly, tree is going to see in this session. First of all, before going to see the trees data structure, first of all, we want to know about the data structure. So what is by data structure? So data structure is nothing. It's a way of organizing the data, not only for organizing the data, it is also relationship with each other data. So that's what we are calling as a data structure. Data is nothing. So information structure is nothing. So organizing the data. So that's what data structure. So some example of data structure: arrays, linked list, stack, queue, graph, tree, etc. These are the example of data structure. In this data structure widely used in many point of view in our computer science and information technology relevant, like OS, compiler design, artificial intelligence, and graphics, many more things we are using in this get data structure concept. That's what we are very, it's a very familiar subject in our computer science and IT field. Okay. So why we go for data structure? What's the need of data structure? So here I'm mentioning three information on this need of data structure. One is a process of speed. So in this data structure will increase the processor speed, and data search. The searching also is very easy. While using data structure, the searching, we extract the data from our data is a very easy using data structure. And also multiple requests. So many requests are coming from, we want to select the record or select, we want to access those elements or data. So multiple requests are one of the needed for data structures. And what are the advantages of data structure? There are many advantages are available. Here I'm mentioning only three advantages of data structure. One is the efficiency. So efficiency means improving the power, improving the processing speed, improving the data processing, everything. So the efficiency, reusability. So reusability, very important concept, and abstraction. These are the major advantages of when using the data structure concept. So in our data structure, in particularly, we're going to see about the tree. So, because in data structure, formally divided into two different types. One is a primary, the primitive data structure. Another is a non-primitive data structure. In primitive data structure, we are using these primary data types, that is integer, float. These are the primitive data structure. And non-primitive data structure, in this non-primitive data structure, we can divide into two different classifications. One is the linear data structure, and another one is the non-linear data structure. In linear data structure, we are using stack, queue, linked list. These are the linear data structure. What is my linear data structure? Nothing. It's a, we are organizing data in a sequential manner. So one by one we can access. So stack, queue, linked list. These are the one by one we can sequentially can access the elements. So we can ask or call as the linear data structure. And another is a non-linear data structure. In the example of non-linear data structure, three graphs, these are the non-linear data structure because the elements are in non-sequential way. So that's what is this non-sequential or non-linear data structure. In non-linear data structure, we can using this tree and graph. So particularly we're going to see about tree. Here showing means definition of tree. Tree is a non-linear data structure which organizes the data in hierarchical structure, and this is a recursive definition. That is called tree. Or tree is a connected graph without any circuits. Here I am showing which is the correct tree, which is the not correct tree. So here I am mentioning. So first graph, the graph is showing this is not a tree because it's a CDE, is a closed circuit. So that's what we are not called for this tree. So second one we can ask is tree because we can it is non-circuits. So without any circuits here, like this is called tree. Example of tree. Okay, in tree having so many properties. What are the properties in tree? Here mentioning some properties of tree. There is a one and only path between every pair of vertices in a tree. This is the first properties. So each and every node having only one path. So next property is a tree with n vertices has exactly n minus one number of edges. That is second property. If you have five vertices, definitely you have four edges. You having four edges. So the next properties, a graph is a tree if and only if it is minimally connected. This is the another property in tree. Any connected graph with n vertices and n minus edges in a is also a tree. That is also another properties of tree. Here mentioning so many properties, mentioning four properties about tree. In our gate point of view, that is graduate aptitude test in engineering, definitely in our data structure concept, tree is a major one focusing for in data structure. That is 50% of questions asked from trees. The tree in tree having binary tree, aerial tree, so many have different types having. So in this tree, it's a majorly focusing on your data structures. These are the terminologies we are using in tree in data structure. That is a root node, a edge. Edge means nothing, it's a path. That is edge. Then parent node, child node, sibling, a degree of the node, then internal node, leaf node, level of the node, then height of this node, depth, subtree, forest. These are the terminologies we are using in trees. So first of all, I'm focusing on root node. So what is meant by root node in our tree concept? The first node from where the tree originates is called root node. So in any tree, there must be only one root node. So root node having only one. Then next thing, we can never have multiple root nodes in a tree in our data structure. So the example of root node, here showing the example of root node. It is a tree because here no circles, no closed loop. It is a tree. This tree in the A, so many vertices are having A, B, C, D. Like in A is the root node because in every tree, each and every tree having one root node. That is, its originate where it is originated. A is the originate node. So it is a root node of this tree. So A is the root node of tree. The next edge. So here mentioning so many terminologies. Edge also one terminology. So what is by edge? The connecting link between two nodes or two vertices. We have to say the nodes here. In graph, we have to say the vertices, but here in tree, you have to say node. The connecting link between two nodes is called an edge. Okay. Next of all, in a tree with n number of nodes, there are exactly n minus number of edges. This also one properties of our tree. We see previously it's a properties of tree. That is n vertices. You should have n minus one edges. So here mentioning n number of nodes, there are exactly n minus number of one number of edges. Okay. Here, what is the example of edges? Here I'm showing the edges of this tree. Here, that is in bold line. That is dotted line, not dotted line. So bold line. And edges. The A to C, the edge having uh, bolded line. And the next terminology is parent. So the node which has a parent from it, any other node is called a parent node. So in other words, we can say the parent node is the node which has one or more children is called a parent node. Definitely the parent contains children. That was we have to say one or more children is also called a parent node. In a tree, parent node have any number of child nodes. Example, here I listed some example of parent. See, the same tree, A, B, C, like up to K, number of nodes there. Here I'm mentioning parent of B and C. The A is the parent of B and C because A children, who is children of A, B and C is the children of A. So who is parent? A is the parent. So parent of A is B and C. Like he has to say who is the parent of I and J. Example, I and J is the leaf node. In parent of this I and J is E is the parent. So here mentioning so many parent, that is node A is the parent of node B and C. Then node B is the parent of node D, E, F, and node C is the parent of, that is C is the parent of node G and H. E is the parent of I and J. Then G is the parent of K. So I'm mentioning some parents. The last nodes like D, I, J, K, H. This I have no parents because no childrens. That we have to not, we are not representing the parent. So the in a parent node, so number of children is there, definitely that is called parent node. Then children, that is child node. Which one is the child node? The node which is descendant of some node is called child node. All the nodes except root node are child nodes. For example of child node, see that see the tree. The child of B. Who is the child of B? D is the child of B. And also E is also child of B because E is there from B itself. So B is the E is the child of B. F also child of B, and uh, I is the child of E. J is the child of E. Here I am mentioning the node B and C are the children of uh, node A. So A is the parent node of B and C. So B and C are children of the A. After that, D and E and F also. D, E, F are children of node B. G, H is children of node C. So likewise, I and J are the children of node E. K is the children of node G. Here are the example of children node. What is the sibling? Next terminology in tree. Sometimes they will ask so many terminology in our gate point of view. So here siblings. What is a sibling? Node which belongs to the same parent. That is called a sibling. We can say other words. Node with the same parent are sibling nodes. For example of sibling node, here I am saying some example of sibling node. See, sibling node ij. Ij are leaf node, but parent of in the ij are both of the node having same parent. So E is the parent of I and J. So these are the siblings because the node having same parent. That is called sibling. So G and H, another example. G and H is the sibling because G and H is the siblings of C. Likewise. So I and J are sibling because I and J having same parent. E is the parent of I and J. So that is what we mentioning some siblings. So likewise B and C. B and C also siblings of who is the parent? A is the parent. So B and C are having same parent. So that we can say that B and C are the sibling node of A. Likewise. The next terminology, degree of the node. So degree of the node is the total number of children of that node. That is called degree of the node. We can say another way, degree of a tree is the highest degree of node among all the nodes in the tree. Like see the example here, degree. So degree of B is 3. So, likewise, see degree of A. Degree of A, how many children is having in A? 2 children, B and C. So, degree of A is 2. Then degree of B is 3 because B having 3 children, like D, E, F children of B. So, B having 3. Like C. C is the degree of 2 because G and H are children of C. So C degree of C is 2. Then degree of D, which is the degree of D. D is nothing. So no outgoing edges or no children. So the degree is 0. So number of outgoing edges, that is called degree. We can say another word. Number of outgoing edges also, that is called degree. So degree of F, which is the degree of F? F having no children. So degree of F is 0. Degree of G is 1 because G having one children. K is the one children. So degree of G is 1. So here mentioning in your tree, mention all the nodes. So which is the degree of all nodes. The degree of K is 0 because K having no childrens. Like next of all, internal node. What is my internal node? A node which has at least one children, that is called internal node. So if the node having one children, at least minimum one children, the node is an internal node. The internal node also non-terminal nodes. We can say another term. We can represent another term, that is non-terminal node. Also, internal node. Every non-leaf nodes are the internal node because leaf nodes are no internal node. So, what is the definition of our internal node? Internal node is at least that is minimum one child is called internal node. Okay. So here's some example of internal node. So internal node, which is B is internode and C is also internode. A, B, C, E and H, A, B, C, E and G. Okay, we are mentioning A, B, C, E, G are internal nodes because they are the parents. A is the parent of B and C. So B is also parent of D, E, F. So E is the parent. So every leaf node is not having an internal node. Non-leaf nodes are having internal. So internal, we can say the internal node. Next node, leaf node. So what is my leaf node? The node which does not have any children, that is called leaf node. Leaf node are some that is we can say represent another way. The leaf nodes are also called as a external node or terminal node. There is no children about the leaf node. So here mentioning some leaf nodes. So leaf nodes are like D is the leaf node because no children here after D. So I is the leaf node, J is the leaf node, then K also leaf node, and the H also leaf node because the F also leaf node. So D, I, J, F, K, H, these are the leaf nodes of this particular tree. We are mentioning so many nodes in our tree. So leaf node is nothing, no children. That is the last node is called leaf node. Another way you can represent. On the next thing, level of the node. So how you can mention the level of node? In a tree, each step from top to bottom is called level. So level count start from 0 because you can take the root node, the level is 0. So level is can take this level from 0 itself and also increment by 1 by 1. So if it is go for next level, it will be increment by 1. So take the example of level. So see the root node, A is the here in this tree, A is the root node. So root node having here, whenever you have to say root node, the root node level is 0. So next level 1. Now level 1 in this tree, example of tree, B and C, B and C are level 1. Then next D, E, F, G, H. These are the level 2. And next of all, last leaf nodes like I, J, K. These are the level 3. So level we can represent so one by one from originate from the root node. Root node, whenever you can say the root node is level 0, and you can increment one by one. What is the height? This is also one of the terminology we were using tree. The total number of edges that lies on the longest path from any leaf node to a particular node is called height of the tree node. So that height represents from the from longest, that is longest path from path to up to leaf node. The height of the tree is height of the root node. Based upon the root node only, we have to consider the height. The height of leaf node height is 0. Now we can say the height of leaf node is 0. Here, the height of tree like B node. B is the height of B. Take the example of B. The height is 2 because leaf node the level leaf node the height is 0. Then before that D, E, F, G, H, these are the level 1, height 1. After that B is the height 2. Like height of node A is 3 because we can count from leaf node itself. Leaf node level is 0. Then after that D, E, H as like at that level is called 1. B, C level is 2, and this A root node, that is 3 because the height of tree we can measure from leaf node itself. So leaf node become always 0. Then depth. Now before that we can see height. Now we can going to see depth. How you can measure the depth of tree? The total number of edges from root node to a particular node is called depth of that node. Here mentioning some definition. What is the depth of that node? And also depth of a tree is total number of edges from root node to leaf node in longest path. Depth of root node equal to 0, the term level and depth are used interchangeably. See example of depth node. Here I am mentioning, here left side I am mentioning some tree. Like right side mentioning what are the depth of each and every node represented in a tree. So depth of node A is 0. Depth of node B, depth is 1. Depth of node C is also 1. Depth of E is represented as a 2. E represent to, D represent to, F also represent to 2, G, H, these are the representing depth. Depth of that is depth is 2 because we have to depth derived from the root node. Then depth of I, J, K, likewise this the depth in from depth we can represent from root node. So the depth of I, J, K is 3. So level is different, height is also different, depth is also different. These are the terminology. Definitely they will ask in get point of view this question. What is how you can measure the level, how you can measure the depth, how you can measure the that is degree, okay, height, depth, level, degree and all. The next thing, what is the subtree? Each side from a node form a subtree, that is recursively. We can see the subtree in our example point of view. That is already we drawn the diagram in tree diagram. The subtree. These are the subtrees. So C, G, H, K. These are the subtree. Left side D, B, F. This is also a subtree D, B, F, E, I, J, and particularly E, I, J also a subtree. Okay. We are mentioning some example of subtree. What is my forest? Forest is a set of disjoint trees. Here mentioning some example the forest. So disjoint set you can represent as a forest. So this before that we have to see many terminologies available from our tree. So first of all definition, what is by tree? Before going to see the in-depth point of view in our tree, we have to see many more terminologies. What are the terminologies available in tree? Likewise, degree, level, depth, height, and also leaf node or terminal node. So we can see many terminologies. Now going to see tree traversal, very important in gate point of view. Tree traversal is important. Basically, in before going to tree traversal, What are the searching of, that is, what are the applications of tree? So basically, in breadth first search and depth first search, we are using in our tree, not tree terminology. Sorry, in our tree, not for the tree, that is, we go for graphs in breadth first search and depth first search. In tree traversal, majorly we can focus on three different types of tree traversal. One is an in pre-order traversal, in-order traversal, post-order tree traversal. We can see one by one. What is my pre-order? What is my in-order? What is my post-order? This is the algorithm for pre-order tree traversal. The pre-order means pre means we can visit, first of all, this is the root node. After then only you consider the left node and right child. That is left child and right child. So first of all, we visit the root node. So these are the procedure, that is root, left, right in our pre-order tree traversal. So what are the algorithm saying? Visit the root node, then traverse the left subtree, that is called pre-order left subtree, and traverse the right subtree. So these three things are the major algorithm of pre-order traversal. We can see example of pre-order traversal. Very, very important in gate point of view. Definitely from our data structure subject, they'll ask one question from our pre, that is basically pre-traversal. Okay, the example of our tree. So here I was showing. So A, B, C, D, E, F, G. These are the nodes. We can represent the tree. And then the pre-order tree traversal. I already said the pre-order tree traversal, saying first of all this is the root node, then you can go for left child, then last finally we can go for right child. These are the procedure or algorithm for the pre-order tree traversal. In pre-order tree traversal, first of all, this is the root node. Which is the root node? Here in mentioning in our example tree, A is the root node for the corresponding tree. So A, this first of all, this is the A. Then go for left child. Left side, that is left children. Left children, which is the, who is the left children of A? B is the left children. So now B is the root of, that is B is the parent of D and E. So first of all, this is the root node. Which is the root node of D and E? B is the root node. So we go for first of all visit the root node. So A first already visited, then come to the left side. In the left side, root node is B. So first of all, B is the visited. So that's what we saying. A, then B. Then B, after B, we go for left side. Left side is considered the D. So after, what's our algorithm procedure? We visit the root node, then go for left side. After that, go for right side. So first visit the A, okay, it's over. Then visit the B. B is the root node of D and E. Oh, we already visited. Then we go for left side. Left children of B is who's D. So we can visit the B. So left visited, root node just visited, left also visited. Then go for right side. Right side, in right side of root node B is called E. So we can visit the E also. So after that, the left side is over. Root node is over. Also left side is over. Left side in B, D is also over. We go for right side. So right side of A, root node. Right side of A is C, F, G. So go for C, F, G side. C is the root node of F and G. So first visit the root node C. So we visit the C. Then we go for F. And then left side. And we go for right side of G. This is the procedure of pre-order tree traversal. See, this is the example of the same tree. Here I was seeing first visit the visit start, here start the A, then after that B is also visited, then go for D is visited. After visiting D, left side is over, to go for right side E is also visited. So left side is over. Once left side is over, then go for right side C is the root node, so visit the C. After that we go for F, then finally we go for G. So what are the applications of this pre-order tree traversal? Pre-order tree traversal is used to get the prefix expression in tree. So this is free. One application is the prefix expression. We normally prefix, infix, prefix, postfix conversion in our stack point of view. So in our application, pre-order tree traversal go for prefix expressions. The next application, pre-order tree traversal is used to create a copy of the tree. This is one copy of the tree. Okay, this is pre-order tree traversal. Then next we go for next second one, in order tree traversal. Basically, the tree traversal is three different types. One is the pre-order, another one is in order, that is post order, another one is in order. We go for second one. That is already we discussed about the pre-order. Pre-order is over. Then go for in order tree traversal. That is second one. That is the in order tree traversal. The algorithm is showing the procedure of in order tree traversal is first we got to visit the left side or left subtree, then we go for the root node, and finally we got to go for right node. So these are the procedure of in order tree traversal. He is mentioning three steps. First step is traverse the left subtree, that is called in order. Then visit the root node after traverse the right subtree. The finally we have to bold the that is the line bolded left root node and right side node. This is the in order. The example we can going to see about the in order tree traversal. See, like same example here mentioning what is the in order tree traversal. So our in order tree traversal, that is our procedure is, that is algorithmic point of view, is first visit the left child, then we go for root node. After that only finally we go for right child. So you take this tree. A is the root node. So first we visit the left child. So left child of A is B. Now B is the root node of D and E. What is the procedure? Go for left child of root node. So B is the now root node of D and E. So go for left side. Left side is D. So first we go to visit the D node. Then you go for check the root node. Root node of D is B. So visit the B. So that only here mentioning D is the first node. Then after B is the second node. So DB is okay. Left side root node. Then right side of B is which one? E is the right side of B. So we visit the right side of B. So E is also visited. Now D, B, E is visited. That is left child is visited. Then go for root node. Root node of B, D, E is root node is, which is the root node? A is the root node of left side. So visit the root node. Root node A is visited here. After that we go for right side. That is right child, and C is the root node of F and G. In this root node, consider go for left side. Left side F is the left side of C. So F is visited. Then go for C. Then rather C is the root node of F. So F visited. Then go for C. Then finally we visited G. So this is the in order tree traversal. The basically and the algorithmic point of view, or what is the procedure of in order tree traversal. First we go for the left subtree, left side, then go for root node. After that only go for right node, right child of the node. Okay. So in this example of another example of in order tree traversal. So visit the first of all visit the D, then B, after E, after that A, then go for F, then go for C, then go for G. These are the visiting levels of this in order tree traversal. So what are the applications of in order tree traversal? Here I'm showing some applications of in order tree traversal is useful to get the infix expression of our expression T. Suppose we have to form the I have to say the one example about the in order tree traversal. You have to form the binary search. So basically the binary search tree, it is also one of the crucial point of view in our data structure subject. By basically the binary search tree, the root node, comparing to the root node, it is less than value or minimum value, we go for left side. If it is greatest value, we go for right side. That is the binary search tree principles. Okay. In this principle, we are showing in the binary tree traversal. Okay. After you giving the elements, after you can make it the element in binary search tree, you go for ascending order. We can take the ascending order. Then you have to check whether you are forming a binary trees, whether it is correct or wrong. Okay, once again, we'll go for this one. Sorry for the inconvenience. Here I am showing, we are not showing this slide. Wait for a few minutes, it will be shown. Like, yes. I hope now it is visible. Once again. Visible. So I come on from pre-ordered tree traversal itself. The basically tree traversal majorly we can form three different types of tree traversal: pre-ordered tree traversal, in-order tree traversal, and post-order tree traversal. We can see one by one. Now we're going to see the pre-ordered tree traversal. In this pre-ordered tree traversal, visit the root node. Then uh, after that you have to go for the left side, then go for right side. That is traverse the left subtree and traverse the right subtree. This is the procedure of pre-order tree traversal. So first we go for root node. So visit the root node, then we go for left subtree. That left subtree is B. So visit the B is the now root node of D and E. So visit the root node, that is B. Then we go for left side. Left side is D. So first A visited, B visited, now it's D also visited. Then go for right side. Right side of the D is E. That is root node of B. Left side is D, right side is E. So go for right side. Right side E also visited. In this point of view, the left side is over. Then we go for right side. Right side is C. The C is the root node of F and G. So visit the root node. In root node, that is visit C. And after we go for left side F, then go for right side is G. So in this pre-order tree traversal, A, B, D, E, C, F, G, like that. These what are the applications of pre-order traversal? Here I'm showing how it is going to traverse the pre-order tree traversal. What are the applications? First applications in a prefix expression, which is used in prefix expression of expression tree. And also pre-order tree traversal is used to create a copy of tree, because first we visit the root node, then we go for left children and go for right children. So it's a create a copy of tree. It's one another application of pre-order tree traversal. Then go for second one, in-order tree traversal. In order tree traversal, the left subtree. First we see the left subtree and we go for a root node, then finally we go for the right subtree. So these are the procedure algorithmic steps in order tree traversal. We see the left node and go for root node, and finally we can visit the right children of this particular tree. The example of in order tree traversal. So in our in-order tree traversal, first we go for visit the we can check the root node. Root node is having left node. In this left node, B will come here. You can check the left children of left side of B. Left side of B is D. So visit the D. So leftmost is over, then we go for the root node. So now it's a root node of D is B. Then visit the root node. B is visited. Then we go for right side. Right side E is also there. Now we can visit the E. So left side is over. Then we go for right side. Other root node. So B, D, E are left side of A. A is the root node now. So left side B, that is D, B, E is over. Then go for root node. Root node A is now visited. Then we go for right side. Right side of C. C is the C, F, G is the. In this right side, we go for left children. Left children of right side is F. So visit the F. Then we go for C. After visit the C, we go for G. So this is the in order tree traversal. So what are the applications of in-order tree traversal? In-order tree traversal is used to get infix expression of in-order expression in E. That is a simple example of in-order traversal. First we visit the D, then we go for B, then we go for E, then go for A, then go for F, go for C, and then G. I will say one example of in-order tree traversal. When you go for the binary search tree, in our binary search tree, some rules is there. We have before going to form the binary search tree, some procedure is available because the first node is called the root node. In the next node, we are going to compare the root node. If it is minimum value, you go for left side. If it is maximum value, go for right side. In gate point of view, sometimes they will ask in our binary search tree. How you going to find the how you going to form the binary search tree? So first node everything in our element, first node is an binary that is root node. Is next you can take the next elements comparing to root first element. If it is minimum value, go for left side. If it is maximum value, go for right side. This procedure is following by the binary search tree. So when you form after completion of your binary search tree, you take the in-order tree traversal. All the elements are come to ascending order. If come with the ascending order, then you form the binary tree. Binary search tree is the perfect binary search tree. So you have to assume binary search tree is perfect. That is correct binary search tree. We form as a correct manner when you take the in-order tree traversal of tree. So this is the one step. It is the one of the crucial point. We have to check the whether we have form as a correct binary search tree or not. Okay. Then next is third one, post-order tree traversal. What are the post-order tree traversal? The tree traversal, first of all, this is the left side, then go for right side. After that final stage only, we go for the root node. So here some example of some tree mentioning post-order tree traversal. So like same example of tree, in a post-order tree traversal, first going to left side, then go for right side. After that only we consider the root node. So left side of A is the left side of A, B is the root node. So left side is D. So first visit the left side. So D is no more children in D. So now D is the visited. Left side is visited. Then go for right side. Then left children is the left children of B is D. The right children of B is E. So visit the next node E. So after second steps we go for E. Then this is the root node. So first left side, then right side. Finally, final stage only we go into consider the root node. So D, E visited, then go for B. So now left side is okay, then go for right side. So left children of A is B, D, E. Right children of A is C, F, G. So now left side is over, go for right side. Right side is in A, C. So C is the root node now. Right, left children is F. So first consider the left children, then go for right side. Right side is G is there. So this is the G. Then only go for root node of G. Root node of G is that is parent of G is C. So this is the C. Then left side is over. That is B, D, E is over. Then go for right side. Right side is also over. C, F, G is over. Then we go for look into the root node. So root node is now A. So our procedure of post-order tree traversal D, E, B, F, G, C, then finally A is the visited node. What are the applications of post-order tree traversal? Here three applications are there in post-order tree traversal. First, it is used to postfix expression. So in order is used to infix expression. Pre-order is used to prefix expression. Then post-order is used to postfix expression. Then post-order tree traversal is used to delete the tree. So first word is used to delete the tree. Then this is because it deletes the children first and then it deletes the parent. Okay, so these are the applications of post-order tree traversal. Here I am showing some mentioning some problem statements in our tree point of view. That is, we discussed still now we discuss about tree traversal and what are the basic terminologies in tree. So these are the term. So basically, first of all, the first question is tree in which data type. Sometimes they ask tree is a which data type. So it is a non-linear data structure. Okay, then problem one, first statement, that is if the binary tree in a figure traversed in order, suppose it is traversed in order, then the order in which node is will be visited. So this is our question. Sometimes this type of questions is asked in gate point of view. That's what here I posted in this question. The question is, once again I'll tell you the question. If the binary tree in a figure is traversed in order, then the order in which the nodes will be visited. So here I'm mentioning some solution. So here, how it is in order tree traverse means the order is from left to right it will be visited. So first node is in G, then C, then B, then D, then A, F, finally E. These are the solution of this statement, this problem. So it will be visited from left to right. Okay, that is in order tree traversal. Okay. So in order tree traversal, whenever you go for in order, first of all the procedure or algorithm is done. First visit the left side, then go for root node, then go for right side. These are the procedure. The next problem statement, that is true. Which of the following sequences denotes the post-order tree traversal? Here I will mention some option also. The first option is F, E, G, C, B, D, B, A, and second option mentioned here, third option mentioned here, and fourth option also mentioned here. So post-order tree traversal sequence. So post-order. What is the procedure? What is the algorithm or procedure in post-order tree traversal? First visit the left children, then go for right children. Finally, go for the root node. That is post-order. Okay. Here mentioning some options also. Okay, what is the conclusion? How it is going to see the post-order tree traversal? A solution of post-order tree traversal. See the post-order tree traversal. First look into the left side, then after right side. After that only go for root node. In left side we go for left side. Which is the left side? First of all, G is the correct answer. Okay, because left children of this every node in our tree is G. So G is the correct answer. Then go for right children. Right children of in the example of this G, G is the left subtree of root node C. Now C is the parent node of G. C is the parent node. G is the children node of the parent node. So C right children, that is children of right children is nil. There is no children here in C. So left side okay G. Then go for right side no children. So obviously next visited to the root node. So GC is the next visited node C. So in our option, the second option is correct. Once again. Okay. Next is G, C, D, B, F, E, A is the correct answer. Okay. Now we're going to conclude. We'll see the next session. in our data structure point of view.